So original line, y equals 2x going through the origin. And then the new line, when you move every single point up 2, you get the new equation y equals 2x plus 2 with the same slope. Okay. Similarly, with this one down here, you also have all these points with a y-intercept of 0 and a slope of 2. Okay, so this is y equals 2x. If I move every single point 2 spots to the left, so 2 units to the left, I'm shifting everything. 1, 2, 1, 2, 1, 2. Okay, what's the equation of this line then? Anyone? Okay, so first off, are these two lines parallel? Yeah, so it's just y equals 2x. I know that part. And then the last part is just where's the y-intercept. So in this case, my y-intercept is 4. So plus 4, not plus 2. So when you move left or right, it doesn't just make the y-intercept that. You have to see where the y-intercept is. So in this case, it's at 4, so it's y equals 2x plus 4. Okay. So with these ones right here, when you move it left, right, up, down, whether you sorry, not move. Move doesn't sound fancy enough. We'll say translate. When you translate the line up, down, left, or right, okay, slope stays the same, and you get parallel lines. Okay. Now for the next one, y equals 3x, instead of translating, we're going to talk about rotations. So first off, let's plot this one first. Y equals 3x has a y-intercept of 0. Slope is 3, so up 3 over 1, up 3 over 1, or down 3 over 1, down 3 over 1. Okay. Again, you know the direction of the line based on the positive or negative slope. It's a positive slope, so I know it's rising to the right this way. Okay, so imagine I have a pin at 0, 0, and I rotate it 90 degrees clockwise. Clockwise meaning this way. Okay, 90 degrees. So where does this point go? This point originally is at the coordinates 1 and 3. When I rotate it, where does this point move to? Simon? This point 1 and 3, if I rotate it 90 degrees, where does it become to? Go to?
Negative 1 and 3.
Negative 1 and 3 is up here.
3 negative 1.
3 negative 1, right? Remember x and then y. So there is a connection between the x and y coordinates. So this becomes 3 negative 1. You know that, so even if you are confused and you don't know where that point goes, remember there is always a connection between the coordinates. It won't suddenly become like 2 and 4 or 5 and 8. It's always going to be these same numbers, just a sign change. So this point becomes here. And then this point, same idea. This point was originally 2 and 6. So when I rotate it down to this area, it will become 6 and negative 2. 6, negative 2, like right here. Okay. So the point 0, 0 still stays because that's where your pin is. So when you have a pin and then you move it, no matter what, that 0, 0 point doesn't change. So you can see it does make a 90-degree angle right here. It is What's another word for 90 degree? Yep, perpendicular. Good job. Okay. Uh, so same idea with this one with the 5x. So 5x is like this. When you rotate it, it will become like this again. Does it matter if you rotate it 90 degrees clockwise or 90 degrees counterclockwise? No. Okay, it's the same. So no matter if I turn it this way or turn it this way, it's the same. What if I rotate it 180 degrees? What happens if I rotate my line 180 degrees? Tenzi?
Nothing.
Nothing, right? It will be the same line. So your line going this way will become a line going this way, which is still the same because the arrows are on both sides. So it's the same line. And what if I say, so this is rotating 90 degrees clockwise. What if I say rotate it 270 degrees counterclockwise? Okay. Rotating it 270 degrees this way will give you the same thing. All right. So I might ask you guys that on the test or on the assignment. So know that 90 and 270 is the same. 180 is the original line. Okay. So what conclusion can we make? Oh, sorry. Let me back up a little. So this red line, I know I have a slope of 3. What about the blue line? What's my slope here? Casey? Sorry? -3, negative, close. Noel? -1/3. So if you go from 0, 0 to this point, you went down the elevator 1 and 3 doors to the right. So your slope here is actually -1/3. Okay. So for perpendicular, so conclusion, when you rotate a line 90 degrees or 270 degrees, slope is, what do we call that term for slope? Perpendicular slopes, negative reciprocal. Good. Slope is, slope is perpendicular, which also means negative reciprocal. All right. Second point is if you rotate the line 180 degrees, line, nothing happens to the line. So it results in the same line. So nothing happens. Okay. Okay. Oh, and also, don't forget negative reciprocal. You can see already the red line has a positive slope, and the blue line is going this way. So you know that it's negative. So make sure it's not just reciprocal, not just negative, but negative reciprocal. If the slope is 3, it becomes -1/3. If the slope is -5/8, then it becomes positive 8/5. Right? So this is 3/1, so that's why it's 1/3. Okay. Last part on page 17, number 19 right here. Okay. Y equals 4x. So let me draw this first. Y equals 4x. So rise 4. Okay. Okay, that's my original line. Y equals 4x. And then if I were to flip it over the y-axis, So this is the y-axis, like a mirror. I'm going to flip it over. So this point, instead of 1 and 4, where does it become if I reflect it over? Sorry, Aaron. This is page 17. So this point is 1 and 4. When I reflect it over, Edward, negative 4 over 1 is over here. Remember x and y coordinate. So when you reflect it over the y-axis, it goes here. So it's negative 1 and 4. Not over, but negative 1 comma 4. Right? Because we're not talking about slope, so it's not a fraction. It's a coordinate. Okay, same thing right here. So this one is at negative 1 and 4. When we flip it over, it goes to 1, negative 4. Okay. What is the equation of this line? Of the blue line? Sunny? Y equals negative 4x. Notice this. What can you say about the steepness of these two lines? Let's see. Shrenik, what can you say about the steepness of these two lines?
They both have the same steepness, only just the negative.
Right. Okay. So even though this is negative, it doesn't mean that this is less steep. Remember, steepness only talks about like how diagonal the line is, and you can see it's the same steepness. So whether it's positive or negative, is still the same. You're taking like the absolute slope. Okay. So with reflections, you get the negative slope or the positive slope of each other with the same steepness. Okay. What about if we were to reflect it over the x-axis? So again, this is the original. This is my original line. Okay. Y equals 4x. Okay. If I were to flip this point over the x-axis, where would this point go? So Aiden, this point is at 1 and 4. If I were to flip it over the x-axis, where would this go?
Negative 1, 4.
Negative 1, 4 is over here. X-axis, over the x-axis.
Is well, 1 negative 4.
1 negative 4, that's right. Okay, and then this one though, this one when you flip it over the x, it will go back up here. Okay, so now what do you know? What is the equation of this line? Fujianxia? Negative 4 equation of this would be negative 4x, right? And so what conclusion can we make? No matter where we flip it over the x or flip it over the y, we'll just get the opposite.
If we have a different slope intercept, won't the equations be different?
Say that again?
If we have a different slope intercept other than 0, then the equations will be different.
Yes. So if it's not at 0, 0, then yes, it will be different. So for
Are we going to consider that?
Okay, so let's do one. Let me conclude with this one first. So just to if we reflect over the x or y axis, when we reflect over the x or y axis, steepness of the line stays the same. The line stays A lot of people make the silly mistake of saying because it's negative, then it's a this it's less steep. But remember, it says the same. Says same sign changes. Okay. So now Shrenik's question. We're saying, what if it's not at 0, 0? So let's say we need one, let's say 2 and 2/3, something like that. Okay, so the equation of this line, okay, so this equation of this line is y equals 2 over 3x plus 2. Okay, let's say we are to reflect it over the x-axis. So this point at 0, 2, when we reflect it over the x-axis, where will it go? Simon? 0, -2. Good. Okay. What about this point at 3 and 4? Simon? Yeah. 3 and -4. Perfect. So then our line will look something like this now after we reflect it. And the equation of this new line will become down 2 over 3, so -2 over 3x. Y-intercept is -2. Okay, so right here, when I set my conclusion, all right, notice I didn't talk about the y-intercept because y-intercept could change. What I've mentioned right here is when you reflect it over the x or the y, the steepness of the line stays the same. So here, the steepness of the line stays the same, not necessarily the same slope, right? It still changes signs. So just like a rotation, when you rotate it, the positive become negative or the negative become positive. But be very careful, it's not negative reciprocal. Okay? Negative reciprocal is only when you do rotation of 90 degrees. This is just the negative slope. And then your y-intercept also changes signs. Okay? And then if you were to do a reflection over the y-axis, you'll get a totally different line. Right? You'll get a line that goes this way, like this. But again, the steepness of the line doesn't change. Okay, so is this possible on the test or on the assignment? Yes. So it's not necessarily only at 0, 0. Right? So these are characteristics of lines that you need to know. EQAO does talk about the rotations, reflections, and translations. These three. So you need to know the characteristics. Okay. So last thing I want to talk about. So we should be able to do all this. Just want to do. Okay, I just want to do two quick examples right here. Okay, page 19. Sorry, 18. 18. 18. All right, right here. Just looking at it, can I tell what is my slope? What is my y-intercept? Just looking at this equation. No, why not?
The y it's too wide.
Sorry? Okay, what format is this in?
The wrong format.
The wrong format. Okay, there's a name for it though. This is standard form, right? What form do we want? Slope-intercept form. So we want it in y equals mx plus b form. A lot of time people see this and they make the silly mistake and say that the m is 6 and my y-intercept is 8. It's totally not, because this is not in the right format. This is standard form. And in chapter 4, we did do solving for y, remember? Solving for another variable. So if we were to rewrite this, I'm going to solve for y. So move the 6x over, becomes negative 6x plus 8. And then to solve for y, I move the 2 now. So y equal, divide everything by 2. So this is negative 3x plus 4. So now what is my slope and what is my y-intercept? What's m and what's b? Let's see. Who should I pick on? Vanessa? Okay, what's my slope? What's my y-intercept here then?
The slope is negative 3 and the y-intercept is 4.
Perfect. Thank you. Okay, so you see it's not 6 and 8. It has to be in the correct format. So now I can plot that y-intercept at 4, and my slope is down 3 over 1. Down 3, 1, 2, 3 over 1. Right, and so there's my line. Okay. And like that. Okay. So last week we did a lot of practice when I gave you the equation in slope intercept form, y equals mx plus b. So it was very easy to graph the line. Now it requires you to do a little math before you can plot it. Okay, last thing I want to go over is, what if I give you a line and tell you to give me the equation? Okay. But I don't see any points here. I didn't give you any points. So what do? I didn't give you 2 points. Aiden, what should I do? I didn't give you any points.
You could just get the slope
How do I get the slope?
by looking at the ratio of the up and side.
Okay, between points, right? But I didn't give you any points. So what do you do to? All right, so I want to find the equation of this line, but I didn't give you any points on it. Right? Okay, I could use the point on the x and y intercept, but it could have been the middle of the box. Right? So if I don't give you any points, you can choose your points.
You did give us points, so you made 2 points on the graph.
Okay, fine, this one then. This one then. Okay. Okay, so let's say this one. Notice I didn't give any points. So I want to choose my points. Does it have to be the endpoints where my arrows are? No. Does it have to be the x and y intercept? No. You just want to choose any 2 points that are nice and easy to read off. So let's just say, just for the sake of the lesson, I'm going to choose this one and this one. Right? Okay, so if I don't give you points, choose any 2 points that are easy to read. So let's say it's these 2. So then I just do my slope. Okay, so down 2 over 4. So my slope down 2 over 4. Oh, guess what? I could reduce this to negative 1 over 2. And if that's what I say, if I do negative 1 over 2, I should end up on the line as well. So for every single point. So it's okay if you chose like the far away points, because afterwards when you reduce it, you will still get you will still reduce it down to the lowest form. Right? And then looking at this, what's my y-intercept? This point right here. Film? Negative 1s. Yeah, so Film, can you tell me the equation of this line then?
Y equals negative 1 over 2x minus 1.
Perfect. Okay. this is another common mistake that I always see people do. They write the equation for me, y equals -1/2 minus 1. And then the x disappears. Okay? Happens all the time, every single year. I catch at least 10 people. Okay, so it's not an equation of a, well, y equals -1/2 minus 1 is just a horizontal line at -1.5. Right? So you have to have that x in there. Okay? All diagonal lines have an x and a y in the equation. All right. Okay, so that's all from me. The rest of it, you can actually finish up the whole package. Don't forget we did practice with these ones last week with the inequality. So there are some practice questions on that too. So remember inequality, if it's greater than sign, it means on top above the line. If it's less than, it's below the line. Solid line means greater or equal to or less than or equal to. Dotted line is just greater or less than. Right? So you should be able to finish the rest of this package. Tomorrow, you guys have an assignment. So you need to bring your computer or Chromebook, which a lot of you already have. Okay, so make sure you bring it. I do have extras if you need. Yeah, so tomorrow we'll do an assignment, in-class assignment, short one. All right, and to prepare for it, you can finish off this package. All right, thank you.